Hi everyone, I am Balaji, Assistant Professor, Department of Mechanical Engineering, GRIT, Hyderabad. I would like to explain isometric views and its importance uh, with reference to planes as well as solids. Why it is important isometric views? Because any solid object in orthographic views, we will get only two dimensions in any view, whether it is side view, top view or front view, we will get maximum two dimensions. We cannot find a third dimension in orthographic views. So in order to specify completely a given object, at least two or three different views must be drawn to understand the complete object and specify the complete object. But the advantage here is isometric views. We can draw a single view in which we can see all three dimensions. So we can avoid drawing more number of views. Now let us start with the simple plane figures. As you know, for drawing any plane figures, let us start with the true shape. For example, this rectangle appears in the front view. We need to follow one method. That means we need to draw one horizontal line and one 30 degrees line, one 90 degrees line. This is 30 degrees line, this is 90 degrees line. And we need to transfer these dimensions here. One dimension we have to keep on this inclined 30 degrees line, other side we need to keep on this. So this horizontal line goes to 30 degrees, becomes 30 degrees line. This AB vertical line will be on the vertical line here. So by adopting that procedure, we will get the isometric view of a rectangle. Now this is the isometric view of a given rectangle. If the rectangle appears in the front view as true shape, this is the procedure. Similarly, same rectangle if it appears in the top view. For a given, that means if a rectangular plane parallel to the ground, okay, perpendicular to BP, in that case, the top view is a true shape, right? At the time, we need to draw one 30 degrees line, that is L, and D, one more 30 degrees line. Then we need to transfer this BC, AB. This AB also becomes 30 degrees here. This BC also becomes 30 degrees here. And draw parallel to BC and AB. We will complete this isometric view. Okay, it is simple case. Same concept we can apply for even pentagons, polygons like pentagon, hexagon, like that. Now we will see a triangle. It's a regular one, right? It's isosceles triangle. To apply, to adopt this procedure, we are enclosing this triangle inside a box, AB, so 1, 2 AB. Now again, we will treat 1, 2 AB as a rectangle. We will follow the same procedure as we have done previously. If the triangle appears in the front view, this is the answer. If the triangle appears in the top view, this is the answer. So we can simply transfer this triangle inside this big uh, parallelogram, right? In between AB, this third point of the vertex of this triangle is there, so we can mark with help of compass. Similarly, pentagon just enclosed in a rectangular box. So in the front view, if the true shape is in the front view, this is the answer. If the true shape is in the top view, this is the answer. Similarly, you can apply for the circular plane. We can divide the circle into four parts. This method, we know that the four center method, we will use this four center method to construct the ellipse, because circle becomes ellipse in case of isometric view. Okay, if the circle appears in the top view, that is true shape appears in the top view, so we need to go by 30 degrees here, 30 degrees here. So you will get using this four center method, you can find out this ellipse. If it is a the circle appears in the front view, same four center method you can draw like this. That is one 30 degrees line, one vertical line. Okay, so this we familiarly known as any other irregular shapes. We can use the same methodology. We will get the different views in the front view and top views. So these are different things. Now let us move on to the solids. Now only the difference between the solids and planes is axis height. So for example, if you had a pentagonal prism, if its axis having some 60 or 70 mm, suppose the pentagon appears in the front view. So we have created earlier like this, right? One vertical line, one 30 degrees line. We have created this pentagon, right? Now this is only base of the prism. Now just extend from ABCD is extend axis length of these edges are nothing but axis length. Automatically you can find out the other end has one more pentagon. Okay, one more pentagon. Actually, this is pentagon. One, two, three sides only I am showing. Remaining three are two sides. Remaining two sides may not be visible. Maybe you need not put dotted lines. Directly you can remove completely to show it as isometric view. So in this way, we can extend the concept for prisms and pyramids also. Okay, just watch these animated videos or PPT, you can easily understand. Now here you see, first I am constructing the base. For example, the difference between this problem and this problem is this axis is vertical, here the axis is horizontal. Here where the front view appears the true shape, here the top view appears as the true shape. So here I am getting 30 degrees lines. Here one vertical line and one 30 degrees line. Otherwise both are same, the only the difference. Okay, similarly you can extend this concept for any other cylindrical object. These are horizontal cylinder, it's vertical cylinder. Now there are so many things. It's a frustum. Frustum, you know that if the solid is cut parallel to the ground at a particular height from the base, we will get generally it as a frustum of a any square pyramid or cone. So again, the concept here is in the front view it is a trapezoid, something like this, because at the cutting portion you will find a small square because it's a square pyramid. So the dimension generally given. You need to draw this top view and front view for understanding purpose, and we need to use these top view dimensions in the isometric view. So this is must. This top view must be drawn. Okay, and now you see this small square having side 20, big square is having side 40. Now in the top view, generally we are getting the square base or true shapes. So let us take 30 degrees and 30 degrees. Follow the procedure you can construct it. So first what I am doing is the 40 mm square I am constructing both ends, but because it is pyramid I am taking a midpoint here. Okay, so there is a small square at this particular cut portion, right? So I am inserting that square. It appears as rhombus in the isometric view. So base already one big square is already created. Simply join the corners. That appears as frustum of a pyramid. You can apply the concept for cone also. Okay. So it is a frustum of pentagonal pyramid. It is another example, similar example. Okay, we need to create one big hexagon here, small hexagon here. Just simply join. Cone is a classical example, right? At this cutting area, there is a small circle seen in the top view, big circle that is the base circle of the cone. Again, it's a both 30 degrees lines because top is a true shape. So first I will create big circle at the bottom and small circle at the top using 4 center method again. 4 center method advantage is you need not use freehand to draw the curve. Directly can use the compass to get the ellipses. Tangential you can join both ellipses that represents the isometric view of the given frustum of cone. I hope you can able to answer remaining any uh, isometric views. Okay, so I thank you.